In this screencast, we're going to take a look at how to use Codap as a replacement for Fathom in doing simulations. In this particular problem, Andrew asked if he was attractive, and when he asked that question, he got 21 yes responses and 3 no responses. When Bridget asked a separate randomly selected group of 24 students, she only got 6 yeses and 18 no responses. So the question is Andrew biasing the results? Assuming the girls who found Andrew attractive would say yes, no matter how the question was asked, whether it was asked by Andrew himself or by Bridget, the question is how likely is it to get results like the ones seen in this experiment by chance alone? To figure out the answer to this question with a simulation, we're going to use Codap. And so to use Codap, you would go to Codap and choose the link for educators. We'll click on Codap here. We'll say create a new document, and I'm going to drag a table down here, a new table, and we'll call our new data set name will be Andrew, and our attribute here we're going to rename as attractive. Now there were a total of 27 students that said that Andrew was attractive, so yes. So I'm going to type in 27 yeses. That represents the 21 students that said yes when Andrew asked the question, plus the 6 students that said yes when Bridget asked the question. We also need to enter the letter N a total of 21 times to represent the 21 students that said no, that they did not find Andrew attractive. So when we're done, we'll have a total of 48 cases here. 48 students that answered the question, was Andrew attractive? The next thing we're going to do is we're going to sample from these 48 cases of yeses and nos, and we're going to see if we can figure out how likely is it if we selected 24 at random that we would get 21 yeses by chance alone. So we're going to choose this plugin called the sampler, and we are going to choose the collector. And notice this collector actually has all the yeses and nos that are in this data set. Under options, we're going to choose without replacement because we would not select a person and ask them this question, put them back in the pile and ask them the question again. So we're going to say without replacement, and we're going to select 24 students. To see how this works, let's just begin by choosing one sample, and I'm going to speed this up just a little bit here, and I'm going to say start. So imagine that these balls are in a hopper, and there are 27 labeled with a Y and 21 labeled with an N, and we're selecting 24 of them from the hopper. And notice the Y's and N's are being recorded to the right. And now they're recorded over here in this table. So we've done this simulation one time, selecting 24 cases out of these 48. And in this first time that we did this, we had these yeses and nos that you see here. So we could go through and we could just count up how many yeses and nos there are, but it'd be easier if Codap would do that for us. So I'm going to click on the plus sign here and create this new attribute called count. I'm going to click on count here and I'm going to create a formula. I'm going to insert a function, and it's a statistical function called count. If you wanted to know how this works with some examples, you could click on the eye with the circle here to the right. I want to count on the attribute attractive. And I'm going to filter out and just count the ones that where attractive was equal to a Y. And let's say apply. So notice our count here is 16. If we went over here and counted up how many Y's we had, there would be 16 Y's. Let's create a dot plot to record our count of yeses. So to do that, I'm going to grab a graph off the shelf here, just one graph off the shelf, and I'm going to drag this word count over here onto the x-axis. So I've got one dot on my dot plot so far, but we want to do this simulation many, many times. So let's do this simulation 100 times in total. So I'm going to do 99 more samples, and we're going to have this go as fast as possible. I'll click start. And so notice the dots are appearing over here. Remember, Andrew had 21 yeses when he asked the question. So is it likely to get 21 yeses by chance alone? Or is Andrew biasing the results? It looks like the most common number of yeses, if Andrew would ask the question, it would be 13. And there's one time where our simulation says he would get 19 yeses by chance alone, but he never got 21 yeses by chance alone in this simulation. So it does appear that Andrew is biasing the results by asking if he's attractive instead of Bridget.